Hi everyone. In this video, I'm going to talk about how to compute a limit. So for the computation of a limit, actually normally we will try to put the direct substitution. That means we will substitute the value of x directly into the function to get the answer for the limit. So if you have passed, okay, meaning that substitution method is passed, this means that when you substitute the a into the fx, you get a value which is defined, which will be represented as a f of a. Then you say that your method of substitution is passed, yeah, is a success. Then if let's say you got a value when you substitute the a into the fx and the gx, you got a 0 over 0, meaning that you obtaining the form of indeterminate form, means that this substitution method for this function is failed. So you got to proceed to the another method, that is by using the factorization or multiply by its conjugate. So normally for the factorization, if your fx and gx consist of a polynomial functions, then we will use the method of factorization. If your fx or gx exists the third form, then means that you need to apply the multiply by its conjugate method. Then after these two methods have after either one you have done, then we will try to simplify the function, and later on we will use back the substitution method to evaluate the limits. As an example, I have to find the limit of 4. The function is 4 when the t is approaches to 3. So if you have a constant function, we don't care what is the value of t approaches to. The answer of the limit is 4. All right, this can be actually explained by using the graph of y equals to 4. Okay, so as if that this is your y equals to 4, x-axis and y-axis. This is the 4. And when x approaches to 3, 3 may be somewhere here. When x approaches to 3, the y is actually approaches to 4. So from the graph, you can very obviously can see that the answer has to be 4. Okay, if you change the t value, I mean the t approaches to -3 maybe, the y also approaches to 4. For a constant function, this is the method we evaluate the limit. Another example, I have a square root of x minus 2, all right, of the function fx. So I want to find the limit of this function when the x approaches to 4. So for this question, we can just use direct substitution method, which I have mentioned just now. To compute the limit, firstly, we will use direct substitution method first. If there is success, okay, our method is success, means that we got a value of a defined value, means that we already got the answer for the limit. If let's say we got the 0 over 0, when we use substitution method, we got 0 over 0, then you need to proceed to either factorization or multiply by its conjugate or both of them. So for this question, we actually can directly use substitution method. That means substitute 4 into the x. Then you have a square root of 2. All right, so 2. So this is the answer for this limit. For the question C, we have to find the limit of 2e power of x plus 1 when x approaches to 1. So for the same thing, you always start with the direct substitution. Substitute the 1 into the x. You get the 2e squared. This is your answer. For the example, another example D. Again, we are using the substitution method. Substitute the 2 into the x over here. Then you got a log of 2 minus 1 plus 5. Right? Okay, so you have a log 1 plus 5. Log 1 is 0 plus 5 means that the final answer is 5. Another example involve the absolute value. You got a modulus of x minus 2. The same thing, though we don't care what the function involved, but we just use the substitute method. Substitute 3 into the x. You got the 3 minus 2, and the absolute value of this, that is a modulus of 1. All right, final answer is 1. Just like that. Let's try the different example. Okay, look at this example. You have a 2 plus r square minus 4 over r. So when I use substitution method, I try to substitute 0 into the r. I got a 2 plus 0, that is 2, 2 square, 4, 4 minus 4, you get the 0 on top. And when you substitute the 0 into the denominator, you also get the 0. So when you have this case, you call this case as an indeterminate form. Alright, meaning that your substitution method is failed. So when your substitution method is failed, we are going to proceed either factorization or multiply by its conjugate. Look at the function itself. We have a polynomial as a numerator and a polynomial as a denominator. So when you have a polynomial divided by a polynomial, we are going to use factorization. So how are we going to factorize it? Firstly, I need to expand this first. 4 plus 4r plus r squared minus 4 divided by r. So we can see that at the numerator there is a 4 minus 4, means that I can simplify the 4 first. Alright, 4 minus 4 will be 0, and what you have here is 4r plus r squared over r. So what makes the r to be 0 when you get indeterminate case? Alright, you get the 0 at the denominator because of the r over here. When you substitute the 0 into this r, you get 0. Alright, so I want to find another r which is appear in the numerator so that it can be cancelled off with the r here. Means that I need to find one r on top of here, on top of the at the numerator. I need to factor out the r. I got 4 plus, okay, 4 plus r over r. So from here you can see that this r can be cancelled off. When the r cancel off, means that when you can back to the substitution method, which it wouldn't give you the indeterminate form. Okay, so now you can just put your r equals 0 into the r over here, you get 4 plus 0. That means your answer is 4. So this is the case that your substitution method failed initially. Then you need to use factorization. After that, use back the substitution method. Finally, you can get your answer. Another example is x cubed minus 8 over x squared minus 4. Alright, you can see that when you substitute the 2 into the x over here, you get the 0 on top. And when you substitute the 2 into the denominator, you also get the 0. Again, when you get the 0 over 0, you say that substitution method failed. Alright, so when you fail in substitution, we are trying to use factorization because we can see that numerator and denominator also consist of polynomial. So to factorize x cubed minus 8 a little bit harder, but for the x squared minus 4, you can see that you can actually factorize easily by writing them into x plus 2, x minus 2. Okay, so just ask yourself, x plus 2 or x minus 2 makes you get the 0 over here when you substitute the x equals to 2. Alright, surely your answer, okay, is this one. The x minus 2 is the one who makes you get the 0 over here. Okay, when you substitute the 2 into it, you get 0 over here. So I need to eliminate the x minus 2. So to eliminate the x minus 2 at the denominator, I need to find another x minus 2 at the numerator. Alright, means that I need to convert the x cubed minus 8 into x minus 2 multiplied by another quadratic factor. And down here, we just remain as a x plus 2, x minus 2. And how do I get this quadratic factor? I can use a long division or comparing coefficient method so that to get the quadratic factor over here. Here, I use the long division, means that I need to use the x cubed minus 8 divided by x minus 2. So I will just write x cubed minus 8 as a x cubed plus 0x squared plus 0x minus 8, and they are divided by x minus 2. When you divide, you will get x squared multiplied by x, you get the x cubed minus 2x squared. And then take the top row minus the second row, you get 0, and this one you get the 2x squared. How do you get the 2x squared? You're taking the 0x squared minus negative 2x squared, so that negative you got positive. Alright, break down the 0x and negative 8. Alright, then focus on the head of the leading term over here. 2x squared divided by x, you get a positive 2x. Alright, you get the 2x squared minus 4x. Then again minus the first row. Alright, minus the first row, the second row, you get a 4x over here minus 8. Then again, the leading term of 4x divided by x, you get positive 4. Alright, 4x minus 4 multiplied by negative 2, you get negative 8. We know that you should know you will get the 0 remainder, because when you substitute the 2 into the x cubed minus 8, you get 0, right? Means that the 2 is the 0 of x cubed minus 8. If the 2 is the 0 of x cubed minus 8, means that x minus 2 will be the factor of x cubed minus 8. Means that if you're taking this x cubed minus 8 divided by its factor, you should get the remainder 0. Means our quadratic factor will be x squared plus 2x plus 4. So when you have this form, easily for you to see that, alright, x minus 2 and x minus 2 can be cancelled off. Alright, when you cancel off the x minus 2, you can see that your function become x squared plus 2x plus 4 divided by x plus 2. I'm wondering that you notice that I have written my steps. My notation of the limit always will be there. Alright, most of the students will say, okay, the limit always repeating. So can I just ignore it? Cannot. Yeah, you must write the notation of the limit as you haven't started the substitution. If I want to start the substitution now, then yes, your notation of the limit can be just ignored. Alright, so now I want to start my substitution. Just substitute the 2 into the x. You get 2 squared plus 2 multiplied by 2 plus 4 divided by 2 plus 2. So you can see that when I start the substitution, there is no limit notation in front of it. So I'll get 4, 4, 4, 12. And this is divided by 4. The final answer is 3. Let's look at this example where the function appear the surd into it. Alright, so when you have this type of question, always start with the substitution. When you want to evaluate limit, always start with the direct substitution. Try to substitute the 2 into the x. You get the 2 minus 2, 0 on top. All right. And then when you put the 2 at the denominator, you get a 2 minus 2. You also get the 0 at the denominator. So when you have a cert, your function is involving the square root, we need to consider multiply by its conjugate, just as the flowchart that I showed you initially. All right. So I write down the limit notation. This x minus 2 just remain as x minus 2. And everything I copy back, and now I decided to multiply the denominator by x plus 2 plus 2, which is this is the conjugate of this. All right, so when the denominator multiplied by its conjugate, we need to multiply the same thing at the numerator so that it won't affect the function. All right, then what do we need to do now is we just expand the conjugate only. All right, numerator just remain it as a x minus 2 multiplied by square root of x plus 2 plus 2. We are not going to expand the numerator, just expand the denominator. So third multiplied by third, you got a x plus 2, and then plus 2 third minus 2 third will be cancelled off each other. Negative 2 multiplied by positive 2, you get negative 2. Negative 4, sorry. All right. Then we simplified it. Simplify the denominator. Okay. You got x minus 2. So from here we can see that x minus 2 is the one who make us get the 0 initially. All right. We see that this is the 0. Why we get this 0? Because of the x minus 2 make us to get the 0. So now we want to cancel off this x minus 2. So we find the x minus 2. We found x minus 2 actually appear in numerator. So we cancel off it. Then our function become like this. Yeah. Now we can use substitution method in order to evaluate the limit. So just put the 2 inside here. You get 2 plus 2 plus 2. Set of 4, you get a 2. 2 plus 2, that will be 4. This is our final answer. All right. Thank you for watching.